Okay. Checking 1, 2, 3, 4. Check, check, check. All right, I think it's working. Um, Welcome everybody. This is the natural gas um, lecture for this week, and lecture 4, wonderful world of natural gas. And then tomorrow I'll probably post up the wonderful world of oil. Okay, and then we'll start into week 4. Okay, I hope you guys are keeping up with the readings about peak oil and how this natural gas stuff, this LNG that we'll talk about here, is like really catching on. Okay, because this, lecture, we're gonna talk about natural gas and how it's formed. We're gonna talk about the various grades of the natural gas, the production and the uses of natural gas over time, and the various ways natural gas is transported to its final uses. Because this is really becoming one of the most popular fossil fuels we use. As we've seen that graphs before, it's about 23% of our fossil fuel consumption. I'm pretty sure that around that number. Okay, natural gas has been around for a long, long time. All right, it was first used in America in about 1816 in Baltimore. It fueled the street lamps. All right, so we've been using it. So we just another oil, and we knew how to extract it. It was kind of, sometimes you can walk around, it's natural. You could see it coming out of the ground, and you could light it on fire. All right, there's natural things like that. It's not all. I don't know if you guys watched that video. I talked about that movie, Gasland, right? Where they're lighting the sinks on fire and lighting the rivers on fire. Okay, those sinks and rivers didn't happen like that before. All right, but there has been times when people have drilled down into the water table and have their water catch on fire because there's natural gas in the water. That's a natural formation. So it does happen. All right. Um, and then in 1920, Hart dug the first natural gas well outside of this town in Fredonia, so New York. All right, and that's what formed the first national natural gas company. Right, in 1858. So it's been around for a while. So we've been experimenting with this stuff and learning how to compress it and transport for some time now. Right, and it's really stayed under the radar. I'm surprised that it hadn't caught on faster, but that's just basically all about economics. It was a lot cheaper to burn coal than it was to burn natural gas. That's just the way it was. Okay. Um, Natural gas is growing in importance, though, okay, because natural gas produces only about half the CO2 as equivalent amount of coal. So it's being substituted rapidly for our electrical generation, okay? Now, we still, as an ecological economist, I still have to say, with the caveat that we got to do the total throughput of all the greenhouse gases, because when we drill for natural gas, it's form methane, and methane is actually a more potent. So natural gas in its raw form, in its molecule form there, in the atmosphere floating around, right, is more potent than CO2. Okay, meaning it traps more latent heat, about 10 times more latent heat than CO2 does in the atmosphere. Does not last as long in the atmosphere, but it definitely traps more heat. So we still got to do the whole calculation to make sure we're not overdoing it on methane as well, right? Methane emissions as well. More than half of the world's proven natural gas reserves are in the Middle East and the former Soviet Union. So we're going to go back and we'll see who has what around the world. We have a little pie chart coming up. All right, the total ultimate recoverable, but it's not us. It's not the United States. So they have more than half, those two countries, right? And we're not included in that. The total ultimately recoverable natural gas resources in the world are estimated about 10,000 trillion cubic feet. Current gas reserves represent roughly about a 60-year supply at present usage rates, and that is a worldwide number, right? So at our current consumption rates, and we used everything, we got about a 60-year supply. And you can decide whether or not that's going to last enough, or we can find more, or we can get better at using it as well. So that's kind of harder if that number is concrete, but that's like peak oil and peak natural gas stuff that we're talking about, right? So the energy that plants originally obtained from the sun is stored in the chemical bonds of natural gas. All right. So natural gas is a non-renewable resource because it cannot be replenished in a human time frame. All right. So it, uh, natural gas is basically just the exhalation of uh, bacteria that we're going to talk about here in a second. All right, but it comes from the sun. All right, the sun's energy, and we have the plants that are able to produce. Let's just go to that. Let's just go to the graph. All right, so we got right here. We got the sunlight coming down. This is the source of all energy on the earth. Okay, without the sunlight, we'd be beat. All right, we had no life on earth. So the sunlight bears down here, and the vegetation is magically able to form the photosynthesis and turn that light energy into chemical energy and store that chemical energy inside of itself, okay, for us to eat later. Or, all right, it does its thing, it goes through its whole life cycle, all right, and dies on off and floats down to the bottom of the ocean or into like a little swampy area. And these little bacteria right here start eating it. All right, and these bacteria are basically bacteria that live without oxygen. And I don't know if you've ever been like on a side of a pond, right? And you walk in there and you put your foot in that big black goopy stuff, right? You pull it out and it starts smelling, right? Congratulations, that is the beginning. If you know that smell, that is the beginning of natural gas right there. All right, that's you. You're releasing the stink of that anaerobic bacteria, the exhalation of that anaerobic bacteria. Now it's the beginning of natural gas, right? But it takes millions of years, so it's not really renewable, right? Because you got to power it up and move it around and do some compression, and it turns into that fine French wine. But we're going to talk about that's not necessarily true. I think it's renewable. We'll talk about that in a little bit, all right? But the bacteria exhales the CH, all right? And this is what we're going after, all right? This natural gas right here, all right? And some of it gets caught up in the peat, and then we'll get caught into the, and then goes through the rock cycle, all right? Some of it never makes it out; it just gets covered up into a big old hole or something like that, all right? And it comes out of the oxygen, or comes out of the water, it turns into CO2 or CH4, all right, depending on how it gets, if it gets, how it gets goes through that water area, okay, and then it goes back and the cycle starts all over again, all right. And this CH4 is the more potent greenhouse gas, okay, and it will eventually turn into CO2, and probably I think it's like 15 years or something like that, maybe a little bit longer, all right. But CO2 lasts until forever. All right, unless it gets sucked down into the plants, because the plants can take the CO2 in. It can't take the CH4 in though. It just stays out there. Okay. So natural gas comes in a lot of different forms. We got the conventional conventional gas well that there's just in here underneath the crude, a rock layer. All right, and we found just a little pocket of stuff that was just left over that all the bacteria ate, and everything that was left over was some stuff on the bottom, and all their smell, all their gas, or all their exhalation trapped underneath there, and we just stick a straw down there and suck it on out. Right? Most of these right here, these conventional gas wells, are basically almost gone. We might find some more. All right, but in my humble opinion, I think geologists know what they're doing, and they've looked all over the place for this stuff. So we'll see. All right, how much more we find. All right, go ahead and look. I'm not going to stop you. But we have this other way. What we do right now is get into the shale, right? So lo and behold, this is like kind of like the peat. All right, they got in there, and there's just layers. The shale has layers, right? And the natural gas is kind of inside those layers and rocked and trapped inside of this shale. And that's what we'll frack. And we drill down there, we go across ways and blow it on up, and then pressurize it with water and water injection and some chemicals and stuff like that to clean it up, and it flows on up just like a conventional well. Okay. We can also see that what's called tight sand gas. All right, these are like what if you read through that uh, sheet, the Post Carbon Institute's critique of the EIA's estimate how much oil we have left. This is what they mean by the tight plays. All right, they're right in like just with little tiny pockets. All right, it's not one big old we got it going on thing. All right, these tight pockets that are, you know, not normally, nice and easily seen by the radar and stuff like that. Right, and you got to drill a couple more to get all just as much gas out of there. Also, in our conventional oil rigs, there's always going to be a little bit of gas there. They kind of come together, right? A lot of times you have them. So a lot of times, you'll see you go down to the oil fields in Texas, you'll see them flaring off this natural gas. They don't even sell it anymore. All right, it's a big controversy. Why aren't you capping that? But the price just stay right. Okay, we'll go over prices here in a little bit too. And we also have what's called coal bed methane. All right, one of the original natural gases that we found. Okay, we were always fighting this problem with coal bed methane. Inside the coal, there's going to be that natural gas too. There's anaerobic bacteria with all that organic matter, and that anaerobic bacteria exhaled and got stuck in that coal. Right? That makes sense. And this stuff, we just usually just vent it on out. And one of the things that really making that fire, I think I talked about that fire of that coal mine in Pennsylvania that's been on fire for 40 years or something. A lot of that burning is just the methane release from there. Right? It's not really coal. Okay, it's not the coal necessarily driving that fire. It's also that methane. Not to say there's no coal there, but okay. So we have a lot of ways, and this is the easy way. This is the hard way. This is the hard way. All right. And this way is not, it's nice, but we're running out of these little spots too. All right. And then we have to start looking for these. And when we find these, we're going to get that oil is going to be in a lot of these too. These little tight sand plays. Okay. These tight plays. Natural gas industry. So we just take it from the oil and gas well. We do a little bit of separation. All right. Try to get the impurities out of there and the oil and the natural gas and then the water. We try to separate the different products that we have inside of there. All right. And we are venting and flaring right here. So we're releasing some of that methane right into the atmosphere, that CH2 that we need to put into that greenhouse gas calculation. I'm not averse to doing it, using natural gas, but let's be honest about the whole equation. Make sense? Okay. Then after we get out of these commodities, these things out of here, clean it up a little bit, it goes to the processing plant, right, where it's refined a little bit more, and we'll talk about some of that refining, right, and we'll take out any non-hydrocarbon gases, right. So we want less leftover carbon chains, right. That's what we're going after. We're going after those carbon chains because we want to burn it, right, and we want to get a good big bang for our buck. So the more stuff we have in that, and oil and water and non-hydrocarbons, it's not going to burn as efficiently. And the different grades of natural gas depend on how clean it really is, right? And then some will be returned to the field for storage, right? Um, and some will be vented and flared as well in that gas processing plant. Then we take it to what's called a compressor station, which we'll talk about compression here in a little bit too, and where it just shrinks it on down. So when we compress it, it becomes easier to move down the pipeline, right? And it goes down to the main sales, and that can go out to either natural gas company or down to underground storage tanks. Okay, and that natural gas company can either sell it as a liquid natural gas, right? Or they can sell it to the consumers that heats the buildings and things like that, right? So it goes out to the final end user from the natural gas companies. So you got the well people, then the well people will clean it and sell it to the gas processing plant, and the gas processing plant will take it to and sell it to the mainline sales. And this is where the stock market stuff happens. All right, this is where all the futures and stuff like that are happening too. All right, basic price. So memory, they say that natural gas is a renewable, is a non-renewable energy. But in my humble opinion, I think it is renewable. Right? It's just that it's harder to do for mass production. And we'll talk a little bit more about this in what's called the biofuel section that's coming up at the end of this class, all right? But basically, what we can do is take all this livestock waste, crops waste, wastewater, and food waste. Because if you remember, it all starts by this stuff dying and being eaten by this bacteria. We can do the same thing. It's called an anaerobic digester. So we take all that stuff that's dead, our poop or old crops, wastewater and food waste, and we just throw it in an anaerobic digester. And that, lo and behold, those guys breathe out the stuff and natural gas, and it ends up being a biogas, and we can turn it into heat, turn it into electricity, all right? And then we can run our cars on it too, as we'll talk about here, and make it into a liquid fuel if you wanted to, all right? And the leftovers from all this stuff, guess what? This is like basically compost, right? And it's a lot cleaner, and there's no lead or mercury or any of that rigmarole left over. All right, we don't have to clean it all on up. All right, all that stuff that drops off, and we throw it down and sell it for organic compost because it's basically what it is. All right, but we'll talk about that a little bit more in the biofuel section. So I just always have to bring that up because I always think that natural gas is renewable. It just now coal, that's a different story. And oil, we'll also talk about that too. Properties of natural gas. So natural gas is odorless. You might say, well, I can smell it. Well, we have to put that in there so for safety reasons. All right, but basically, it's basically odorless. So it goes from that stinky stuff that you step in the street in the pond, right, and turns into a gasless, odorless. So we have to put some more odor to it. All right, so we know, canary in the coal mine isn't always around. Okay. So natural gas is a hydrocarbon gas mixture consisting basically of what's called methane. All right. So natural gas, when everybody says that, it's really a methane. All right. And then there's various grades, and we'll talk about it here in a second. There are various grades of this methane. Okay. And that's the common terms more. Okay. Varying amounts of other high alkalines. So there's some alkalinity. Natural gas is very high in alkalinities. It's the main source of helium too. So when we get out this natural gas, all those balloons that were blowing up and stuff like that, all right, is coming from taking that non-hydrocarbon out of there, okay, and separating them. Right? So I should say helium's a hydrocarbon. Wait, helium's not a hydrocarbon. It's thinking hydrogen. All right, but we take the helium out, and that's where we get all our helium for our balloons. Lesser percentage of carbon dioxide. All right, that's another reason why we want to use it because there's less carbon dioxide for the release of CO2 in the atmosphere. And it's not that methane is not more potent; it just doesn't last as long. Okay, and there's a lot of nitrogen also in the natural gas that we get out of the ground there, and this is great for the farmers. All right, so another thing that us ecological economists like to look at is what's called eutrophication, the algae blooms and dead zones that we're seeing in our waterways. I don't know if you guys ever heard of those things, like down in Florida, where last summer they had a whole bunch of dead fish all over the place. All right, every year just Google the the Gulf dead zone, right? Just the Gulf of Mexico dead zone, and you'll learn all about the dead zone. But that's basically nitrogen that's pouring off our farmlands, and those farmers are getting that to the nitrogen. And farmers, they're smart people, and we're working on it. All right, we're working on it very hard to put just the right amount of nitrogen down so the plants don't do it. But plants are smart; they only take up so much nitrogen. Well, let me say, I think plants are smart. All right, that's not a scientific. I can't scientifically prove that. All right, but they only take up as much nitrogen as they need. Okay, but nitrogen is really cheap, and the farmers can just throw that lickety split, and if they waste a little, they don't really care. Okay, because it's really cheap, and they can't really pinpoint it to get it to the roots and all this other stuff. So there, in a sense, there was a lot of extra nitrogen on the ground, and that washed into our waterways, and nitrogen's a food for the plants that helps them get the green, and it just causes those algae blooms, and the algae blooms up, and that algae takes out all the oxygen out of the water, and all the fish go away. Okay, but that's a little bit beyond this class. But that's another problem with the natural gas that we need to address. We need to have that in the equation of whether or not we want to use natural gas, or if we can avoid this, then go for it, right? And there's ways to avoid this, of course. And there's also what's called hydrogen sulfate inside of the natural gas. But what you basically know is what you use. You use the methane, right, for your natural gas. Okay. But there's also that nitrogen, which is a big part of it, right? Propane, which is a little bit cleaner, right? So the propane you probably use for the heating of the pool, and we can move that around a little bit. There's a different price for that as well. There's just a little bit of carbon dioxide, and then there's butane and pentane. Right? So butane's in our lighters, right? So what can one uh, unit of natural gas do? Right? So one unit of natural gas can uh, do 4.6 days of space heat warming a home to 65, where the average temperature is 45, right? And this is kind of, got to take this with a little grain of salt, because we've got to make sure what the R factor is and all this other stuff. So, we can definitely bring that down through efficiencies, what have you. All right. But basically, we have 4 days of heating an average size home. Right. 49 days, we turn into electricity. 49 days to wash, like a 15-degree V. All right. 10 days of hot water. All right. We get 63 pounds of ammonia, producing enough fertilizer for a half acre of corn. All right. Um, we can put it into a car, get 276 miles um, of natural gas in the Honda Civic, right? Or on the bus, the CNG bus is 224 miles. Okay. So you can get some good stuff out of here, right? But there's a lot of different things. So direct gas utilization, generating electricity, producing fertilizers and foods, and even doing our fuels. And if we want to do all this stuff, do we have enough natural gas? Is it worth building a huge new infrastructure for our natural gas cars? I mean, is that a reasonable question to ask? I think so. And that's the kind of things I ask as an ecological economist. And yeah, we need to, I need engineers out there to figure out how to build this stuff if we decide to go for it, right? So, proof of natural gas reserves by region. So, you got to remember, United States, here we are, North America, 5.3%. Okay? And like I said, Middle East is the highest with 40, and Russia. So, they have more than half of the, almost 75%. Close to it, 68%, whatever that ends up being. I can't do math this morning, 64%. So North America only has 5.3% of the proven natural gas reserves by region. All right? And please note, this says North America. This does not say the United States of America. So when we say, 5.3, how much is that is Canada's, and how much is that is ours, and how much is that is Mexico's? Because sometimes people throw Mexico in this North America say. All right, so be aware of that. All right? They could say North America, but you understand what North America means in these kinds of charts when they're talking about energy on a global scale. All right, so America is not, United States is not America. Okay. Africa and Asia, 7.8 and 8.8, and South and Central America, 4%, and Europe, 9%, 9.7. So Europe has a little, and this is shared all between Europe and other, right? So each place, so just because it says Europe, Germany, I don't think they have any, right? They might have a little bit, but not enough to run their economy on. They have to get it from another country. Yeah, and guess who's real close? Russia's real close, right? But over here in North America, we want to start shipping them over here. That's kind of that geopolitical stuff that we were talking about before. I mean, they really have the power. Is it really worth us building all these LNG plants to ship that stuff out to Europe for them to use and not us to use here in the United States? Kind of questions I like to ask. So the consumption of natural gas in the United States, you can see, has this is the blue line right here. There was hardly any use of natural gas before 1900s, of course, right? And then it slowly started ticking up during the Industrial Revolution, right? The use of fossil fuels allowed us to become who we are today. I'm telling you, it's magic. All Da Vinci's machines started working. Imagine that. Um, Natural gas just skyrocketed up to being in second place to petroleum. Right? Coal, kept up with it, but you can see it's a nice little decline here. I shouldn't say nice little. I feel like I'm being mean. Nice little decline of coal. But that decline is because basically the electrical use. You can see it's almost exactly the same as the natural gas increase, right? And that's because it's replacing natural gas is replacing coal for electricity, right? So consumption by sector, okay? So industry has slowly but surely declined their use of natural gas in the field, all right? But you can see, like I said, electrical power has definitely increased, all right? Our heating of homes has basically stayed consistent, all right? And our commercial use for heating our commercial use has already also stayed consistent. So even though the industrial use has gone down, our electrical power has gone up, all right? And this might be, since this is also the United States. This is the United States of America. One of the reasons why our industrial use has gone down is also our manufacturing has gone down. All right, so we have not as much usage, not as much people working in that field. So that just makes sense that the industrial area is going to decrease. Make sense? So price of natural gas. So when you go to the market here, they use what's called the Henry Hub natural spot gas spot prices. And this is right off the wellhead or whatever. All right, so this is kind of like the Wall Street price when you're talking features and things like that. All right, this is where it all starts from. Okay, and you can see it's not really. I mean, you can probably plot a nice line and scatter scatter plot this and put a nice line to it, fit a nice curve to it, and it probably just going down like this. Probably has a nice little curve up and a curve down. Oh yeah, here we'll just go down here and look at it. All right. So here's the Henry Hub in Europe. So you can see, it fluctuates. Okay, on a monthly basis. Okay, and a daily basis. You can see we have two different big spikes right here in 2005, 2010. And a pretty nice consistent of being over $6 a cubic foot here. All right, BTU. And this is when the fracking really started taking off in this little era. Okay, um, and you may say, hey, well, why did it take off here? And why it's a price up? It's 2020 and we're still drilling. Well, they had the plans. All right, they already put the money into it. All right, and it takes some time. So this is when they started doing it because of the price and started expanding as much as they could. Okay, hoping that the price may come back up because it didn't really fall and flatline until recently, down to $2 to trading about $3 today. So that's what it was today or something like that. I think it was around $3, 3.30. But you don't need to know that. So the monthly nominal natural gas compared to Europe and Japan. If you see here, this is the U.S. price. And then the yellow is Europe and the black is Japan. So you see a nice little disparity in the price, right? So what would you rather do after you find this stuff? Would you rather sell it in the open market where the price is a little bit higher or keep it here? And that's one of the reasons why we're increasing our production because we're trying to do what's called LNG. We're going to talk about that in a little bit here. All right, and shipping it over there so we can start competing in Europe and over there in Japan. Okay. Not only are we competing to try to get this on a global ground, but this is also a natural security risk too. All right, And we take this stuff out, but we also have what's called a strategic reserves kind of thing. All right, it's called strategic reserves. So it's working gas and underground storage compared. We keep some just for problems. If we need to, go into war, we have 6 months of natural gas already refined and ready to take it out. All right, and it varies during times. All right, and sometimes you might hear, I haven't heard this talk for a long time because we just have had a glut of oil and natural gas. But it's called strategic. It's called I guess we did last time the oil went down, but it wasn't the natural gas. We'll talk about that in the oil section about that day. All right, don't worry. We'll talk about the day oil went to negative prices. All right, because there was already too much stuff in storage. All right, so we need to watch this too. We can't overstore because sometimes we have too much natural gas on the marketplace and we can't put it in the ground. The prices will collapse and they'll get even smaller. And that's one of the reasons why we have an oversupply. We're always stored up here, and we have an oversupply of natural gas, and we got to get rid of it. But we'll talk about the day that the oil went to negative in the next section, in the next one. But basically, what it is just a depleted field, all right? And we take that stuff, we clean it all up, and we put it down in the depleted field. And we have this little rig on top of it, so it's ready to go. Right, we can just turn a little button and boom, we got our pipelines and running again. All right, nothing to worry about. It's already refined, all the toxins are taken out. We do this not as much as we do the vacant salt cabin. So we've mined out all these big salt caverns. All right, and we've taken the salt out and we sold it. And now all we got is a big hole in the ground. Right, and we take the compressed or natural gas and stick it down there in the salt mine. Right? And this is where we also put our oil as well. Okay? Or we're taking it into a depleted aquifer. We already took out all the water. There's a nice little hole that we know there's out there, and we'll put the natural gas in there, and we can just flip a switch, and it's off to the races. Okay? So to get all of this stuff down there, we have to actually compress the natural gas. All right? And compressed natural gas, methane stored at high pressures. It can be used in place of gasoline, petrol, diesel fuel, or propane, or anything we want it to. So we just have to really compress. CNG is made of compressing natural gas with mainly composed methane and CH. It's less than 1% of volume it occupies at standard atmospheric pressures. So we need to compress this on down so we can actually handle it a little bit easier and have less storage needs. Okay, and it is stored and distributed in hard containers at pressure of 200 mpps, usually a cylinder or a spherical shape. So your propane gas is the thing that you use to grill with is actually compressed natural gas, right? And that propane is part of that natural gas that we get out of the ground there, right? And it's easier, it's nice and light. But if that was out, first we have to store it somehow. And how do we store it? We just can't might as well build a smaller unit and compress it on down and hold it on that pressure, so it's easier to store when you use less room. Okay, it's kind of smart how we figure that stuff out. Right? And these can be as big as a little propane tank, or it can be as big as a big old dome. Right? Like you see here, these little domes. Sometimes you'll see these little domes on on side of the street, stuff at a plant that you drive by. And these are actually sometimes they can be liquid. These are liquid natural gas, but it can also be the compressed natural gas in those little storage units too. So we do that compression, but we also do what's called liquid natural gas because we can even get it into a tighter formation and easier storage and easier transportation, especially if we're going across the United States. All right. So instead of putting each one of these a whole bunch of propane containers on here, all right, we put it in. We liquefy the natural gas. Okay, which is converted to liquid. We kind of basically freeze it. All right, and that takes up about 1/600th of the volume of old natural gas as a gaseous state. And it is also odorless and colorless and non-toxic and non-corrosive, just like natural gas. in its natural state. Okay, but we're basically just freezing it on down and making it into a bigger solid. So we go in, into a liquid. I should say solid, into a liquid. Okay, so we compress it. Here in America, when we're just using it just for transfer it to next use, final use here in America. But if we want to get it all the way over to Japan, we have to liquefy it and put it on the boat to get it over there. Okay. So how LG reaches the computer? So it just goes natural gas production, all right, and we liquefy it. We put it on a boat. We ship it on out there, and then once it gets to the end use, we put it on a look on the pipelines right at port. Right, we heat it up, turn it into a gas, and send it on out to its users. All right, and this is a good jobs program. Right, you can see the worker right here in the middle of the graphic, right? So it's definitely going to create a lot of jobs. Okay, but as an ecological economist, I always have to ask how long those jobs are going to last. Well, they're going to last as long as we have some propane or natural gas to produce, right? So as long as these natural gas keeps on producing, we'll be all right because the environmental damage is a little bit less and the price is right. So why not ship it over there? But we need to have a lot of smart engineers out there to be able to do this because as we estimate here in the United States that most of our net exports are going to be liquefied natural gas. Right? You can see that we want to increase that. That's what we're planning on doing here in the United States. All right, and these are our estimates of, industry estimates, I should say. Okay, and you can see that's a big jump, right? Of course, we're gonna, still gonna run our pipelines from Canada and Mexico and all those other things up there, but we want to try to increase this industry. Okay, and we have about 22.6, 52% of proposed. How we're going to get there is going to be about 52% are still in the proposal station of these liquefied natural gas areas. 7% of it is actually already existing. We got 9% on the construction, right? And 8% that is about, or 19% that's about approved. All right. So to get to here, we're almost there. All right. We got half of them. We have the proposals, but over half of them are way about to be built. All right. And if you just do a little Google search on, liquefied natural gas projects and plants, a lot of jobs in this area. All right. This is just the Louisiana coast of Texas. So these are the plants that they're thinking about doing so they can ship out to um, put on the Gulf of Mexico and ride on out the Gulf. You can go to England over here. You can go to Europe over here, all right, or you can go down to the canal and cut over and go to Japan, all right. So this is a great little port area, and we already have a lot of the existing pipelines running into this area, into the Gulf of Mexico from the oil. All right, they're already separating a lot of the natural gas. I already told you about them flaring a lot of that stuff out. So instead of flaring it, they have to be able to capture it and sell it. All right, and this is one of the reasons why we're building this stuff is to stop some of that flaring that's going down around in Texas. So we just have an oversupply and nowhere to get rid of it. All right, because our demand in the United States really hasn't been going up, right? Except for the electrical use. Okay. And one more thing before we stop. That was the end of it, but I just wanted to touch on one little thing. I remember I talked about how fracking was able to get away with the Clean Water Act, right? And instead of being a big old coal plant where we could see and say, hey, you are the one, emitting all that pollution, right? What they were able to say is, hey, we're kind of like a, one little pad, right? And you can't tell me that this little pad is going to cause that much damage. So you can't come after me. And they will say, hey, this is my little pad. You can't come after me. I didn't do it. All right. It's what's called a non-point source pollution. Okay. So it can't be tracked back to any one of these wells. They can't take the blame to it. And that's how they were categorized. All right, and that's how they kind of did it. But you can see the speckling of the pads. Each one's about 3 miles away, or whatever. All right, and it just peppers the pad. This is the Wyoming's. All right, we look the same here in Allegheny County. If you go up, if you took a helicopter ride or you went on Google Earth, you'll see these little areas just like this, tucked away. And you see the pads right here in the beginning, right? And these don't have any because they've already fracked these, right? There's just a little regulator coming up and percolating up that thing, and the pipeline starts and is off to the races, right? And the pipeline just underneath here somewhere, okay? If you come out to my home to see the solar panels and wind turbine, I'll make sure before you leave, I'll make sure that you looked. But you'll see that some of this stuff is going on. They're building a couple of different pads and a pipeline in my neighborhood. And I'll send you down the street and you can see one that's, I don't know if they're flaring it or not. All right, but they're definitely building. You can see the beginning of it. All right, and you can see one that's already done as well. That has just, it's just a transmission line. There's a couple off on the other side of the road. So if you drove throughout my country roads, you would see all these little roadways, but you won't see these pads. All right, they're kind of hidden. They're not as visible. All right, but that's okay. Okay, and it's doing a lot for my community. I tell you that, jobs, jobs, jobs. All right, but I hate my 8 potholes out front. All right, they drive me bonkers. Wish they'd fix them. All right, so in conclusion, natural gas is once again thanks to ancient sunlight. If it wasn't for the sun and the plants doing their things, that anaerobic bacteria would never be able to breathe and do its thing, so we could be using its breath a million years later, right? It's become more popular due to climate concerns, all right? So it releases less CO2 or less greenhouse emissions when it's burned, all right? But we got to do the proper, total throughput equation, and CO2 is not the only greenhouse gas, all right? Let's just be honest about the total calculation of that throughput. Production has definitely increased in the United States and around the world, but it can't keep. Can we keep up with demand? I don't know if we're going to be able to keep up with demand as well. And are we going to have enough to be able to sustain this for 90 years or 60 years, or what they say? All right. Most of the increase though that we're seeing in the United States for our natural gas is forecasted to go for the LNG units. All right, so we can liquefy it and send it over to the higher price markets in Europe and in Japan. The global world is also racing for access. The global world is all racing for access for more natural gas. So watch this space, right? So I've already pointed out a couple times about Germany and Russia trying to build that pipeline, and the United States sanctioning them because we want to be able to get that natural liquid gas. So watch it. I mean, it really, the geopolitical stuff is amazing, right? I was having a conversation with my friend in Afghanistan, and I don't know if I should talk about this, but I'm going to say it anyways. I think Afghanistan was all about a pipeline, right? I mean, I think that pipeline went back all the way back when the Soviet Union was invading Afghanistan. All right, they wanted that territory to get some waterway access. All right, and Afghanistan was in the middle. Okay, it's a fact of life. Um, but is it worth it? Right. So watch this space. This is going to be interesting. There's always some kind of fossil fuel behind almost all of our conflicts, but there's a lot of different things, right, that make us not get along with other people. Okay. I just wish it was an energy. Okay. I mean, geez Louise, there's other ways. We're going to talk about renewable energy coming up here in the second half. I have a lot of better attitude about getting along with people. All right. All right, everybody. Thank you for listening, and we will get the oil one up ASAP for you, probably tomorrow morning. Okay. I had my kids all week, and it's been crazy. I mean, I also had roofers here that were banging all day yesterday, but that's over with. My roof doesn't leak. Thank goodness. All right. Thank goodness for roofers that know how to engineer a nice roof. All right. Thanks, guys. We'll see you next time. Bye bye. Hey, once again, if you have any questions, let me know. Okay.